Hello and welcome back. If you follow the channel, you know that after many difficulties, we successfully connected an ancient 8-inch floppy drive to a semi-modern PC. I want to restore a whole pile of these drives that I picked up in a haul a few years ago, with the ultimate goal of restoring my precious HP 9895 and HP 9885 disk drive units. However, the sticky notes on the drives say that they are faulty, which explains why they were set aside. So let's find out what's wrong with them and see if we can bring them back to life. Starting with floppy drive unit number 2. Alright, so now that we have a good setup to test the disks, we know this one works, and so I want to go through my whole inventory and find which ones work and which one I do have to repair. This one is the one that gave us nothing last time, didn't even seek. And we know it has a problem with the brake, which what I think is the brake that's broken in there. It still moves somewhat, it only binds at the end. So I want to see if I can seek it, and for that you don't need a computer. I just wire the adapter and I am doing the seek line. And I want to see if I can make it move. And kind of moves, not always reliably, but that's a dirty pulse, so it doesn't really matter. But let's see if something happens if it's hooked up to the computer. Okay, will it seek? And should seek at boot. I changed its address to DS1, so now should be addressed properly. Oh yeah, it did. Okay. Alright, so that is much better. So maybe the only thing that's wrong with that one is the brake. Let's see if it gives us any sign of life. Let's make it spin. It spins. Here is a formatted disk. See if it can read it. Okay. Okay, that's normal. First time it doesn't like it. Retry. Ooh, second time doesn't like it at all. Okay, that's not normal. If you have seen the previous floppy episode, you've seen me use the Omnidisk software to help debug floppy drives. It's a little steep of the learning curve, but it allows fine-grained control of the floppy, such as motor on-off, seeking the head to a particular track, reading and identifying sector header information. It's going to be my workhorse in this video. Let's go to Omnidisk drive 1. Cylinder 77, map on. Let's try to seek somewhere in the middle, 40. It did, okay. Seek 0. So the first time it takes a while, don't know why. Okay, that seems to work. Scan. Oh, no signal from the head. Okay, so this one has problems with the read system. That's what's wrong with it. Can't even read from head 0. Okay, so let me rig up the interface, see if I have any index pulses and any read data. The FDC cannot see any, so I suppose it's not making it through. Also from the previous video, we showed Antoine's adapter, which is available on Tindy. All the interface signals are available as test points, so we'll hook ourselves to the index and data lines. Index pin 20, read data is pin 45, and they're all accessible on Antoine's adapter here, so I just need to put a little test pin on. Okay, so that's read data. That should be index. And by the way, this is a little rig I got recently, and it's really helpful. It has little goosenecks that don't have backlash, and I have put a little Amazon link store with all the tools that I discover and use, and that's one's on there. Okay, so here's my problem. I do see the index pulse right here, but there's zero ZPO data coming out, so it's not the index problem, it's the data. So here's index and no data. So just to be sure, I did it on the good disk, and on the good disk I see the right thing. I see the sync pulse, the index pulse, and I see the data out here. So that's what I should see. In order to see that actually without seeking, I just hardwire the address to always select it. Alright, so fortunately we have the schematics for that thing. These are the heads. There is a mechanism to select the head here, and the read for the heads come differentially over here, and then it comes up here. That's the read signal, and it comes here differentially, and there is a video amplifier, quite performant, actually 120 megahertz bandwidth, differential, and then it comes to this weird filter, but I noticed there are test points right on there. It's easy to find where they are right here. So I should get signal over here, and I went and broke out the modern amplifier because this is more serious here. Let's go to head 0 and try to do a scan, and I have ZPO 0 signal. After the first amplifier we have nothing, and it's affecting both heads, because if I do the same test putting Omnidisk on head 1, I don't get anything. So it's either a failure of the head select biasing, or it's the first amplifier. I can just probe directly on the head to figure out if I get anything. I am probing at the input of the amplifier where it's scanning, and I get nothing. That's the green. ZPO 0, absolutely nothing. So I got nothing at the entrance of there, and nothing out. That is really strange, because there's almost nothing but a few diodes, but there could be some select circuitry over here. It's kind of complicated. The selection is done from page over here, from that thing. Then you would think this would not fail both at the same time. This is head select over here. Very strange. I might just compare that with the disk that works, and making sure I should see signal, but I think I should. Okay, this is a good drive, and yeah, plenty of signals. Alright. It's in the head biasing, or the circuit itself that's not working on the other one. Okay, I feel like we're going to have to make some measurements at the head, so I broke out the fancy vintage equipment. This is a differential probe. I might as well. I spent some time restoring it, and you can tell the signal at the head is in blue. So I can check for that now on the bad disk to see at least if there is some signal at the input of the amplifier. Okay, I re-rigged myself with the disk that doesn't work, and I don't see anything. It's so weird to have two heads fail at the same time. So I'm thinking it's the circuitry that drive or select or bias the heads. So I think I understand how the head selection is done. They are just simple diodes, and I suppose they are reverse biased when you choose one head and forward biased when you choose the other one. This diode switching circuit is worth explaining a bit. It is an analog signal switching circuit, which was popular before the advent of JFET transistors and analog switch ICs. The circuit is at first a bit surprising because there appears to be two sets of diodes back to back, so you'd think nothing can go through it. But once you figure out that the diodes are not used as rectifiers but simply as voltage control resistors, it all makes sense. Let's look at the first set of diodes, D1 and D2. One side is positively biased via current limiting resistors to plus 12 volts. If the control voltage on the other side is at plus 24 volts, the diodes are reverse bias and the amplifier is disconnected, inhibiting the reads. But when the read inhibit signal goes to ground, D1 and D2 become conductive and the amplifier is connected to the diodes D3 through D6 downstream. Let's assume the head 0 bias is at plus 12 volts and the head 1 bias is at minus 12 volts. D5 and D6 are reverse biased and present a very high impedance, so head 1 is disconnected. However, D3 and D4 are forward biased and offer a very low resistance, so the amplifier is connected to head 0. If you reverse the head select signals, then head 1 becomes connected to the read amplifier instead. Note that this clever circuit only works under certain conditions. It only works if the signal is small enough that it won't change the forward or reverse biasing of the diodes, which is the case here. The head signal is a few millivolts at most. It also only works if the amplifier is not sensitive to the common mode DC bias of the diodes, which is also the case here, since we use a differential amplifier that's only sensitive to the differential voltage induced by the pickup head. And that's simply done by controlling the voltage on the center wiring. So I look at how this bias voltage was generated, and sure enough, it's generated by the head selection. The head select come over here, and then there are two branches, so you should see the bias toggle, and that shouldn't be subtle, that should be like 5 or 12 volts or something like that. So over here in red you have head select, and in green and yellow you have the biases that are provided to the center winding of the heads. Nothing happens unless you address the disk, and for that I issue a dummy seek. I seek to 20, for example. Okay, so nothing happens. Let's change the head. I was on head 0, so let's do head 1. And let's do another seek. 20. Up! And it changed. So that works correctly, so that's really annoying. So what else could be wrong? Diodes are bad? Or the heads are not close enough to the disk? Something really silly. So I was looking if the heads were touching the disk, and they were. And I see that this one seems to have slipped out. So maybe it's not making a connection, but that would just be head 0. Head 1 should work. Yeah, I push the pin back. And let's try to load the head and see if it's any better. And I see no... There you go. I see no signal. No, nothing. So that was not it. So I'm back with the idea that the head is not aligned properly, and there's something wrong with the seeking. I heard a noise, but I didn't look closely at it. Now if I seek to 0, it goes backwards and it ended up in the same position. If I go seek 77, it hardly moved. Right, it's a major mess in there. There is this broken brake and there's a broken spring. You can see it maybe on the side over there. I'm shining light on it right now. It's not my only problem, because even when I move the heads by hand in a random location and try to bring them down, I still don't get a signal, which I can't understand. But one step at a time. There you go. So that's the pulley. Whee! Alright. So I removed the thing, and now there's the spring in the pulley, and this is what was broken. and I think that's just a simple friction thing. And of course it broke at the hinge, and that's where the spring must be. Yeah, that's the spring. Ooh, that's a strong boy. It's a very strong force that's applied on the thing, and then it broke like this. Okay, I have come up with an alternate solution out of these tongue depressors. I manufacture these great parts just in a pinch so I can keep going, and I think it works. You can turn it, but it definitely holds it. For a trial, that should be good enough. Okay, that works. So it doesn't bind anymore. It feels just about as stiff as the other one. Alright, we're back on. That seemed to have solved our problem. So that's 0. And that's 77. Aha! Okay, so we repaired that. But I suppose we will still not have any signal. So I made a simple experiment. I unplugged the head from this one and put it on this one. So the signal from the head from the bad disc goes to the amplifier of the good disc. And sure enough, if I push the heads manually, I see the signal. So heads working, amplifier or the diodes are bad. Okay, I finally found a way to test the amplifier. I disconnect the head, and then I have to use a transformer to put the input from my signal generator up there. And then finally, that's the input, that's the output. And this is the good amplifier. This is an amplifier that works, so I'm going to figure out if that one is ruled out as non-working. So I'm hooked up to the bad guy, and surprise, surprise, it works! I have a signal at the end of my amplifier. So the head works, the amplifier works, so it's the bias works, so it's the diode network in between? That would be so weird. So the diodes are an early Fairchild chip with plenty of diodes, and they are all over here. So if I test the diodes, that's forward. They all look somewhat good, but then this one looks odd, and the other ones are fine. Then if you test reverse, this is a good one, you get nothing, and this is the bad one. Then maybe not, because we look at the two diodes are different, and they are actually different on that circuit. It's this one and this one, and they both have a resistor in parallel, so they are none of the ones involved in the head. Dang, so maybe that's normal. So if that's not good, my best, brightest idea is maybe that signal is not good. It turns on during the writes, and it probably turns off the reads. Maybe that signal is dead. It's something really silly. Alright, so then I did probe this, and it was at 0 volt on the good board. It's at 0 volt over here. Then I probed this one, it was at 12 volts on the good board, and over here it's at 2.9 volts. So finally I have one discrepancy between the two discs that could explain it. So I'm finally getting somewhere. I was trying to figure out why I had only 2.6 volts here where the other drive showed 12 volts. And I look at where the signal was coming from. There's no 12 volt from there. It's actually driven from over here through this diode, and then we checked the signal here, which I checked before, and I checked that it was toggling, but I didn't check what voltage it should be because I didn't know at the time. But it's 2 point something volts over here too. Then you look where that signal is generated, which I've found since then. It's generated over here. I checked that this toggled, that's the head select, but I never checked that the voltage they were putting out was right, and the voltage is switched from Actually, it took me a while to find out from this weird chain. This is a power-on thingy that prevents the voltage to be applied until the drive is nice and stable. And checked over here, that's the power rail for 12 volts, it's at 3.5 volts. Then I check the collector here, which should be on the plus 12 volts, and it's 3 point something volts too. So is it just 12 volt power supply just bad? Okay, I have to find out how the 12 volts is generated, but I'm amazed that the disk seeks at all, or does all the other things. 12 volts not there. Okay, so on to trying to find where 12 volts comes from. I found the chip, 24 volt in, 12 volt out. Guess where it is? Over there. And I bet you my weekly allocation of bananas that there's not going to be 12 volts out of that one. 24 volts in, ground, 3.9 volts. It's dead, or there's a short, but it's not even warm, so I bet it's dead. Okay, finally we have our 7812. Give it power. And it outputs 0.3 volts. So it's not this, the other 3.9 volt came from somewhere else. So it's totally dead. Dang, a whole day chasing a bad power supply thing. I would have never thought the power supply was bad on that thing because it was working so well, except for a little part. Oh well. Oh no, I hate it when this happens. I had checked the plus 12 volt supply before and it was okay, but I had checked it at the video amplifier. It turns out there are not one but two 12 volt regulators on this board. The second 12 volt is only used for the head bias and is completely independent from the other one, so I had not realized it was bad. To make things worse, some significant voltage was leaking back into the 12 volt power rail, making it appear as if the head bias was working correctly. A very sneaky fault indeed. This is the new LM7812 and I'm checking the bias of the head and it has returned to 12 volts. That's perfect. I hope that's it. That would explain it. Well, I was getting nothing. It just wasn't biasing the diode switching network and I got nothing. And well, so now I'm completely misaligned too. But let's see if I have at least some signal. Yeah, I have signal. I can see it. I just pushed the head in. That was it. It was our diode switching network. Is it going to read anything? Omnidisk. Scan. Yeah, it reads it. Alright. So we might have repaired that disk. We repaired the brake, we repaired the power thing, we repaired the pin that was missing, that was slipped out of the connector. It's wobbly, so it's probably in between two tracks. Probably some realignment to do. So how do you align a drive when you don't have the alignment disk? Well, you take a drive that has been done in another disk that hopefully is aligned. So this one has been formatted in the good drive, and then right now it's aligned, but I use a combination of just the pulley to bring it to track 0, and then after that you just turn the motor until you get, I think that's track 1, and I'll just maximize it on track 0 around here, and that should do it. And now if I go C50, go somewhere in the middle of the drive, C0, go back. Okay, I'm back on it. Let's see if DOS can read it. Directory, yeah, can read it. So into my file directory. Okay, right, floppy 5-inch. There you go, music file. It's reading it. Alright, repaired. Could read the file. We got our disk drive back to life. No more stickers. Excellent.